Hello everyone, welcome to our channel, the Digital Institute of Computing Technology. In this presentation, we will have discussion on the topic Arrays in C. What are arrays? Arrays are nothing but a list of elements having same data type. We can have an array of integer, an array of character, an array of float, etc. We can as well have an array of user-defined data type, like structures and unions. We can have a one-dimensional, two-dimensional, and in general n-dimensional array as listed below. One-dimensional arrays holds elements of same data type in a list. The syntax is data type followed by the array name followed by the size enclosed in square brackets. Example: A is an array of integer of size 10. Two-dimensional array. A matrix-like array with rows and columns. The syntax is data type, array name, followed by rows and columns, once again enclosed in square brackets. Example: matrix is a two-dimensional array of integer having 3 rows and 3 columns. Three-dimensional arrays, an array of arrays of arrays. The syntax is data type followed by array name followed by x, y, z, the 3 planes enclosed in square brackets. Example: cube is a 3-dimensional array of integers with size 2, 2, 2. Now let's discuss one-dimensional arrays in detail. Let's see how to receive values into an array, how to process an array, and how to display an array on the output device. Let's write a simple C program to print the array elements first. In the given example, num is an array of integer of 5 elements. So 5 is the size of the array, num is the name of the array, and int is the data type. The array num has been initialized with values 1, 2, 3, 4, and 5. 1 is the first element of the array, 2 is initialized to the second element, and 5 to the last element. We are running the for loop 5 times as shown. In every iteration, we will print one array element. In the first iteration, I will be 0, so I will print num of 0. Similarly, num of 1 in the second iteration, and finally num of 4 in the last iteration. Note, the indexing in array starts with 0 and ends with n-1. So if you have an array of 5 elements, the indexing for that array will start with 0 and ends with 4. The output of this program is 1, 2, 3, 4, 5. We can run the loop in a similar way and receive 5 inputs. Let's see one more example. In the given example, num is an array of integer of 5 elements and 5 is the size of the array. Num is the name of the array and int is the data type of the array. In this case, the array num is not initialized. We are running the loop 5 times and receiving values into the array. In every iteration, we will receive value for one array element. In the first iteration, I will be 0. So we will receive value for num of 0. Similarly, for num of 1 in the second iteration, and finally num of 4 in the last iteration. When you observe the scanf statement, you see we are passing the address of every array element to the scanf function using the address of operator ampersand. At the end of the loop, all the array elements have been initialized with some values. Now we have the data available inside array num. Let's try to evaluate the sum and the average of these numbers. How do you evaluate? Firstly, let's assume sum is 0 initially and average is also 0. We have to access the 5 array elements. We will run this loop 5 times to access all the 5 array elements. In every iteration, we will access one array element. In the first iteration, I will be 0. So we will access num of 0. Similarly, num of 1 in the second iteration and num of 4 in the last iteration. Sum is initially 0. Then we add up sum with the older value of sum, which is 0, plus num of I, which is nothing but num of 0. Now sum will have the value of num of 0. In the next iteration, I is 1. So sum will have num of 0 plus num of 1. Because the formula we used in the loop is sum assigned sum plus num of I, means the new value of sum is generated by adding the older value of sum with the current value of num of I. So every time the loop runs, the array elements get added up one after the another. So finally, when the loop terminates, variable sum has sum of all the array elements. And average is nothing but sum by 5. The number of elements is 5. So this way, we have evaluated the sum and the average of 5 array elements. The output in this case is the program receives numbers 1, 2, 3, 4, 5 and prints the sum 15, average 3. Remember, in order to process an array of size n, you have to run the loop n times. Now, let's write a program to search the presence of some element in a given array. Basically, there are two methods which are generally used. One is a linear search method and another is a binary search method. Let's first see the linear search. What is linear search? Linear search sequentially checks each element of a list until the target value is found or the list ends. It has a time complexity of order of n. Consider the code in the given example. Here, we are checking the presence of value target inside the array. Assuming the array has 10 elements, iterate the loop 10 times. Now in each iteration, you access one element. Check if any of this element in the array ARR from position 0 to 9 is equal to the target. If yes, return the position of that element. If no, return a value -1 to indicate the element is not found. You can only confirm that the element is not found when you have scanned the entire array. That means you can return a value -1 at the end of the loop. In linear search, we search the entire array to see if the target element is present in the array or not. Now let's see the binary search. What is a binary search? Unlike linear search, which searches the target element in a linear fashion, binary search repeatedly divides a sorted list into two halves. So we have a condition in binary search that the given array should be sorted in a particular order, ascending or descending. And on that basis, it will perform the search. Now let's see binary search. What is binary search? Binary search repeatedly divides a sorted list into two halves, comparing the target value to the middle element and eliminating half the list each time. It has a complexity of order of log n. In binary search, we divide the array into two parts and check whether our element is present in the left half or the right half. And on that basis, we either continue searching in the left part or the right. Initially, the left points to the first element and the right points to the last element of the array. Now, calculate the index mid by adding left and right and dividing the sum by 2. Compare the array element, that is ARR of mid, with the target, the element to be searched. If they are equal, it means we have found the element. The array element is found. Return the position of the element, otherwise the loop continues. Now if they are not equal, there are two possibilities. If array of mid is greater than target, it implies there is a possibility of target being found in the lower half. Reduce the value of right to mid minus 1 and continue the search in the lower half. If A of mid is lesser than target, implies there is a possibility that target could be found in the upper half. Increase the value of left to the mid plus 1 and continue the search in the upper half. This process continues until the left becomes greater than high, implying all the elements have been searched. If the loop terminates without a successful search, return a value minus 1 to indicate the element is not found. For a successful search, return the position of the element, otherwise a value minus 1 is returned. Now let's write a code to invoke both these functions. So let's first invoke the linear search function. So this is the code. ARR is an array of integer with values 10, 20, 30, 40 and 50. The number of elements is 5 here, so we can compute that dynamically by dividing the number of elements calculated by total array size divided by the size of each element. So we can calculate the number of elements by total array size divided by the size of each element. Target is 30, the element to be searched. So first, let's invoke linear search. The linear search has 3 arguments: the array to be searched, the number of elements in that array, and the target element to be searched. So we invoke the function linear search with ARR, variable any, and target. And linear search will return some output. In this test, what output does it return? Since target is 30, this is what happens. Initially, when the value of I is 0, ARR of I is 10, does not match. The loop continues. When I is 1, ARR of I is 20, does not match. But when I is 2, ARR of 2 is 30, which matches target. So value 2, that is the position of the element 30, is returned. In case of an unsuccessful search, like for example, if you are searching 60 or 90 or 0, what would have happened? The entire loop would have executed and it would have not found any element matching the target. So the function would have returned minus. So, but in this case, since the search is successful, it is returning the index of the element, which is nothing but 2. So now let's see how the binary search function. Let's invoke binary search. Once again, it needs 3 arguments: the array to be searched, the number of elements in the array, and the target. Now, once the binary search is invoked, the left variable points to the first element, which is nothing but 0. Right variable points to the last element, which is 5 minus 1 equal to 4, the index of the last element. Since left is less than right, the condition is true, the body of the while loop executes. Mid is evaluated by adding 0 plus 4, which is nothing but 4 divided by 2 becomes 2. So mid becomes 2. So we get ERR of 2, which is nothing but 30, compared with the target 30. They are equal. So mid is returned, which is nothing but 2. So in this case, the binary search function returns 2. The search is successful. What if we were searching something like 90? In that case, we would have ended up searching elements continuously in the upper half. And if we were to search element 0, you would have ended up searching elements continuously in the lower half. So this is how the binary search function works. The output in this case is element 30 found at index 2. A two-dimensional array is a matrix-like array with rows and columns. Let's see an example. In the given example, we have defined a two-dimensional array with 3 rows and 4 columns. Matrix is a two-dimensional array. We have initialized a matrix with some values. 1, 2, 3, 4 is the first row, 5, 6, 7, 8 is the second row, 9, 10, 11, 12 is the third row. Similarly, 1, 5, 9 is the first column, 2, 6, 10 is the second column, 3, 7, 11 is the third column, 4, 8, 12 is the fourth column. To access array elements, here we need 2 loops. In the outer loop, we will access the row of the array, and in the inner loop, we will access the element at each column of that particular row. For example, to access 6, first you should go to the row number 1 and then access 6, which is the column number. So remember, the indexing in array starts with 0 and ends with n minus 1. So if you want to access element in the third row and fourth column, then use A of 2, 3. Index is 1 less than column and row number. Matrix of 0, 0 will use the element in the first row and the first column. Matrix of 0, 1 will use the element in the first row and the second column. Matrix of 1, 2 will use the element in the second row and the third column, and so on. The output of this program is elements in two-dimensional array are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hope you liked and enjoyed the presentation. Remain connected with us by subscribing to this channel for latest updates on this channel. Thank you.